Hi guys, welcome back to the channel. Today I'm gonna do a little tutorial on what dependency injection is and how to use it. I see a lot of these questions coming up on things like the Reddit C# page and on Facebook, and I think it's quite an important concept that people can sometimes struggle to get their head around. And so today I'd like to go through and try and help people out with that. Okay, so the first question is what is a dependency? Now, to begin with, I've just set up this console application quite quickly, and I have brought in the two libraries that I have. Basically, all they are is just a wrapper for structure map. Now, structure map is a third-party library that's freely available, and it is a dependency injection container, and it does things like assembly scanning and all of this kind of stuff, which we will go into in a little bit. But first of all, the big question is that what is exactly a dependency? Okay, so if I have, let's create some classes here. What do we call the class? Class is always a good thing. So we will call this, we shall call this class 1, because we're like that. And we will have this as a sealed class. It is in, no, okay, we'll leave it like that. And we're going to do something with it. We're going to do something. So we're going to say void. We're just going to call this foo. And inside here, we're going to say console.write line class 1 foo. Okay. See it a little bit more. Let's get rid of the unused usings. Great, okay, cool. And inside our main program, we can say var class 1 equals new class 1, and we can call it, and we can run that. We'll run it. And we can see here that we get class 1 foo being output there, which is great. Okay, so we have a class. That's great. Now, what we will do is we will now add another class. Now, let's say, for example, we will call this a logging class. Logging. Let's call this class. I already have a logging. Yeah, let's do that. And again, it's sealed. Always seal your classes if you are not designing them to be inherited. I'm going to say, give it a constructor. You don't have to. Every class in .NET gets an automatic default parameterless constructor, which is why it's kind of grayed out here. But we may be able to, we might do some more things with that. So we shall, so I prefer to add it. And inside here, we will have a function called log, and we will take a message. And what we will do is we can rewrite that. We will write that to the debug screen, and we'll also write it to the console. And we will change the message. So we will say var output equals, use our string concatenation, and we're going to say, okay, we're going to say date time dot UTC now, and we're going to say message. And what we might do, we might do that. Give it, pretty it up a little bit. We're going to want to just use system diagnoser. Again, get rid of that. Okay, so we have our logging class, and we can test that. We can say, what we can do is we can say, we can create a member variable here. Create our constructor. I know I'm a lot of code writing here. class, and we can say logger dot log. We'll call this foo, like that. Now if we run this, we get this. We get some information from our logging output, which is great. Now, logger is a dependency of class 1 because class 1 uses it. It depends on the logger class. And in this case, what we're doing is we are creating a concrete relationship between log class and class 1. Now what we can do is, so that's what a dependency is. It's a class that uses another class, and it has become a dependency forms in that. Now what is dependency injection? Well, in this case, what we're doing is we are creating a concrete object inside the constructor of the class that depends on logger. Dependency injection means that what we do is we actually inject the instance of the class that we want in the constructor of class 1. So what we do here is we say, okay, we'll say log class logger, and we then say, instead of creating a new class here, we do this. So we inject it here, and we use it here. We assign it to our member variable, and we use it here. Now this won't compile because what we need to do is we need to say var logger equals new log class, and then we're gonna inject that, and our program will still run, and we will still get the exact same output. Great, we have that here. Now this is dependency injection. Now there are some useful things that we can do to help us do this stuff kind of in the background and automatically. So in order to do that, we need a couple of interfaces. So I just create the class because, you know, it's easy to do. But I'm going to say log class. That is the interface to the log class. And I'm also going to say, I'm going to create class 1. And we're going to say public interface class, can't spell, class 1. And if I do this, there we go, we can see multiple now. So we're going to change this to public interface log class. If we come up with the log class, we're going to say, right, what we're going to do is we're going to get rid of this because we're not going to use it. But we also want to take this and make it the method that we're going, that this interface exposes. And then we're going to say log class inherits from this interface. That's awesome. That's great. And we can still build that. Yep. We're all good. Yeah, we'll enable that. Yep, thank you very much. And we can still run it. Perfectly valid. Yep, perfectly valid. All we have done is we have basically said that this log class inherits from ilog class, which means inside class 1, what we can do is instead of this being ilog class, instead of being the concrete log class, we can say it is the interface of ilog class. And we just change that to use the interface as well. And we run that again, exact same behavior. But in this time, we're not using the object, we're using the interface. Great. That's great. We will also do the same with class 1. We will have this one as here's from class 1. We'll put that over here so we can see them side by side. And we want to take this guy and say we're going to implement that. This is still going to work. We've changed nothing. We can do that. Inside our program, where we create a new logger, what we can say is we can actually, instead of using the class, we can say these are ilog class and class 1, and they will work exactly the same. But this time what we are doing is we are calling, this is essentially, we're dereferencing. We're creating a new object, but we're then essentially casting it to the base type, which is the interface. That's great. How do we get this happening? What I would love to do is I would love to be able to go, right, let's do some, so what would be nice is I would like to use an IOC container to spin all of this up in the background. Now I have one here. It is based on structure map. So we pull this in. I need to install structure map. That's what I need to do. Do we have that here? Oh, it's in good. Okay, cool. Right. So I have one here. Sorry. And what this does is essentially is a wrapper for structure map. Um, when we create our container, we do some things inside here to get it to scan. We can output things that it looked at. We can also say I would like an instance of a particular type, and then these are helper classes to help me register providers. This is the one that we're going to rely on. Now, with default convention, structure map has a convention tracker, scanner, and what that does is it will say, okay, look for, if we have an interface called iClass1 and a class that is called class1, it basically says this is a convention, and so it will add this to the container so we don't have to do anything special here. It gets automatically discovered. We don't have to go in and say, okay, to register. You see in some source codes, what you have is you have what's known as a bootstrap mechanism. That may be a class, that may be a function, and inside there you may see things like, okay, we're going to bootstrap our dependency injection, and where you have things like, for this particular interface, use this particular class implementation for you. That is registering the provider, and that's not taking advantage of automatic scanning that some DI containers offer the user. And that's quite useful for doing things specifically. So in the Telnet Mud program, we're working on getting data from the database. And one of the things that we can do is using another testing framework called Mock, we can create a new implementation of the Dapper query method, allowing us to essentially override that and return our own data. And then, of course, what happens is because we've created a new implementation, what we do is we tell the IOC container to we re-register our new implementation as the provider. So when the code runs and Dapper goes, I need an instance of this particular interface, the DI container gives Dapper our new modified implementation instead of the default implementation. And that's really the power of dependency injection is you're getting the code to kind of self-discover what it needs to do. And it means you can write code a lot faster, and you can then create everything via interfaces, which conforms to solid methodology, preferring interfaces over concrete implementation. And then you can do things like overriding particular interfaces for testing, and it's really powerful. But back to this, what we're going to do is we're going to say, okay, so we understand that now this is going to create a relationship. This is a convention, so that's absolutely fantastic. So what we can do is we can get rid of this. What we can say is I want to bootstrap my IOC container, and we do that with this piece of code here. Yeah. What this does is it basically creates a new new instance of it, and then it goes through that lazy load procedure that I showed you, and it goes through the scanning, and that's great. And then what we're going to say is we're going to say, okay, once we've done this, we're going to want to get an instance of var1. We don't want to inject, we could inject it here. but we'd have to get the IOC container to spin up sims some other way. You could do that using a static thing, but main would be still unknown to IOC. So yeah, so what we're going to do is we're going to say class1 equals IOC. We're going to do the static stuff, dot of, and the interface that we want is iClass1, and that will give us an instance of class1, and then we should be able just to call that method that's on there. And hopefully, if everything is right, we can run that. We have stopped. Okay, great. Why have we stopped here? It says class1 not found. That's interesting. No default configuration. See, this is where it all falls apart in my demo. Okay. I know why. Because these have to be public. That's why. By default, .NET create, if you don't specify an accessor on your class, it is going to be a internal only class, which means that it is public to the assembly, but not to outside of the assembly. And because when we do assembly scanning, we use reflection to have a look to see what classes are implemented, those have to be public. And here we go. Great, our program runs. We have the log output and we have our actual implementation of the method there. And so what this is doing is we are getting an interface of this. This knows, the dependency injection knows that the I log class is a dependency of class 1. So before it builds up a list of all those dependencies, and what it will do is it will say, great, what we'll do is we will spin up a logger to do that. What we can do is I can show you a quick way of what I can do. Okay, I think we'll leave it there. Another way, what I could do is I could show how we override this. Yeah, let's do that. I've started, so I'll finish. To log. No, I can't spell. See, this is what happens when you do all of this stuff unscripted. You come up with these ideas. We need this. Can't type. Can't spell. Okay, and then we're going to want to implement this. Implement interface, and we will say log, and we will say let's just console. I don't dot write line. What we will do is we will say, for example, you want your release bit to do this. That's great. Let us move this class into the main thing here. Nope. We want it here. There we go. There we go. Yep. And what I can do here is we already know what we will do is we will say IOC.register provider for our wait a second. I have forgotten. It's been a while since I've done this. This is it, register provider. Okay, cool. Great. What we will do is we will say for log class use log class 2, and we want to use that a new per instance. Basically, every time we spin up one of these, we're going to use a new one of these. The other option we have is to use a singleton, which basically means there's only one instance of that. But we're going to do that, and then what we will do is we'll just leave it as such. We'll spin up a new class 1, and instead of using the original log class implementation, we should use the new one. If we run that, and of course this is what we get. We get the stars. And that's the power of dependency injection. Hopefully some of you guys found that useful. Hopefully, it was pretty clear in my explanation. Um, if you did like it and it did help, it'd be great if you would consider subscribing and liking this video. YouTube likes engagement, and that's a great way to grow the channel. But in the meantime, I hope you found it helpful, and thanks for watching.